Welcome to the deep dive. We sift through the sources, the articles, the research, really aiming to bring you the essential insights you need to be truly well-informed. Today, we're tackling something pretty common in environmental chats. This idea that cows are, well, environmental villains, big contributors to climate change.
Right. It's a very widespread belief.
But what if that's only, half the story?
Yeah.
What if the truth is a lot more nuanced, maybe even surprising, maybe hopeful?
It really is. For instance, did you know studies have shown well-managed pastures can actually host like 2 to 3 times more native bees than ungrazed ones?
Wow, okay. That's not what you usually hear.
Exactly. Or that properly managed cows can help pull carbon right out of the atmosphere and store it deep in the ground, potentially making beef, well, carbon neutral, or maybe even carbon negative in some cases.
Okay, these are definitely the surprising connections we want to dig into today.
Yeah, our mission is to get beyond those headlines, help you uncover facts that might just empower you to rethink what you thought you knew about our food system and, the environment.
And we absolutely have to give a huge thanks to Dan Blackburn here. He meticulously curated all the research, all the sources that really underpin today's deep dive. His work gave us so much to talk about.
Absolutely. Great stuff he pulled together.
Okay, let's unpack this. We often see these pristine green lawns as beautiful, right? A sign of a well-kept home.
Yeah, that perfect green carpet.
But what does that perfectly manicured turf actually mean for the tiny, crucial creatures buzzing around us, particularly bees?
Well, it's kind of remarkable how our own aesthetic preferences can, without us realizing it, create these ecological deserts.
Deserts, that's a strong word for a lawn.
But it fits. While a pristine green lawn looks neat to us, for bees, honeybees, wild bees, all of them, it's often just barren wasteland. They need nectar, they need pollen to fuel their flight, usually within maybe a mile or two of their hive. But a huge expanse of just mowed grass with nothing blooming, that's like asking us to trek across a desert with no water. Entomologists point out that many bee populations actually suffer from poor nutrition simply because these landscapes lack the flowering plants they need.
And it's not just the lawns either, is it? You mentioned even some ornamental gardens like certain roses or tulips.
Exactly. Some of those beautiful flowers, certain hybrid roses or tulips, they've been bred purely for looks, not for nectar or pollen production. So they offer very little to a hungry bee. Pretty, yes, but not very helpful for our winged friends. But here's the interesting twist. Those humble weeds we often try so hard to get rid of, clover, dandelions, wild violets, they're actual lifelines for pollinators. Experts literally call a yard that's just grass a floral desert. But letting a bit of that biodiversity creep in, that turns it into a buffet.
A buffet, I like that.
White clover, for example, it offers nectar with really high sugar content, plus protein-rich pollen, and it blooms everywhere. Even a dandelion gives that crucial early spring pollen. So a lawn dotted with these isn't messy to a bee. It's like a rich smorgasbord compared to that sterile green carpet. Maybe we all need to embrace a bit of rebellious gardening,
Embrace the weeds. That's definitely a shift in perspective. So how does that messy lawn compare to, say, a diverse meadow or a properly managed pasture?
Oh, those are truly a bee's paradise. They offer this continuous supply of blooms right from spring through fall. You've got clover, self-heal, goldenrod. They sort of take turns offering meals. Even just a mixed pollinator lawn at home can be a vital refueling stop.
So variety is key.
Absolutely. Bees are efficient foragers. They look for flower patches that give the biggest bang for their buzz, if you like. A patch of clover might have hundreds of tiny florets. That's a bonanza for a bee to just tank up easily.
Makes sense.
And it's not just honeybees either. Roughly 70% of our native bee species actually nest in the ground. They often need little patches of bare soil, maybe between plants. Wildflower-rich grasslands, especially ones that are lightly disturbed, tend to have these open soil patches. So this biodiversity creates more biodiversity, more pollinators mean wildflowers set more seeds, which sustains the whole plant community. It's a cycle.
Okay, now here's where it gets really interesting for me. What role do grazing animals like cows play in this? You'd instinctively think they just eat all the flowers, right?
Yeah, one might assume that. But surprisingly, cows can be essential allies for pollinators, provided the land is managed thoughtfully. There were studies in Montana, for example, that showed grazed pastures hosted 2 to 3 times more native bees than ungrazed ones.
Like 2 to 3 times more bees? That's incredibly counterintuitive. If they're grazing, aren't they munching the flowers and maybe disturbing nests? How does that work out as a net positive?
That's a really good question. It seems paradoxical, but there are several ways well-managed grazing actually helps bees. First, their hoof action, walking around and they're munching, it creates small patches of bare soil. They clear away the dense leaf litter.
Ah, like those ground nesting bees need.
Precisely. That's exactly what those ground nesters need to dig their nests. Ungrazed land can get completely covered by dense, unbroken growth and thick, dead plant litter, leaving basically no spots for nesting. The studies found grazed sites had nearly double the bare soil area, and that directly translated into far more bees nesting and thriving. It's about creating the right kind of disturbance, not just any disturbance.
Okay, so they're sort of tidying up in a way, clearing out the clutter and making room, but selectively. What else?
Second, well-managed grazing can actually increase the floral diversity and abundance in pastures. It's a bit like pruning a garden, actually.
How so?
Well, livestock often prefer to eat grasses rather than the flowering plants, the forbs. So by selectively nibbling the dominant grasses, cows give the wildflowers a competitive edge, more space and light to grow. The USDA even notes that pollinators and well-managed pasture land really go hand in hand. In effect, cows can prevent one or two grass species from just taking over everything. They help maintain a mosaic of different plant types, including wildflowers, which naturally leads to richer pollinator diversity.
And you mentioned a poetic synergy earlier. It really does sound like a partnership. Can you elaborate on that? What's happening at the ecosystem level, that mutual reinforcement?
It truly is a profound partnership when managed right. You have bees pollinating the clovers and other forage plants that the cows eat. This ensures those plants remain abundant and productive in the pasture.
Right, keeping the cow's food source going.
Exactly. And in turn, the cow's grazing keeps the habitat open, prevents it from becoming too overgrown for the bees, and their manure adds nutrients back to the soil, helping those very plants grow lush. It's this mutual reinforcement loop. Pollinators boost pasture productivity, and the grazing maintains the pollinator habitat. It just fundamentally counters that simple cows versus environment narrative we hear so often. It can be a win for bees, and by extension, a win for the whole ecosystem. And, if we connect this to the bigger picture, the benefits of healthy grasslands go way beyond just the bees. They extend deep into the very soil beneath our feet, which naturally leads us to ask, how do cows fit into the whole climate change discussion?
Right, we always hear about planting trees to absorb carbon, but are you saying there's this huge carbon storage potential right under our feet in grasslands?
Absolutely. It's often overlooked, but healthy grasslands are formidable carbon sinks. Prairie and grassland systems, because of their deep-rooting plants, contain much more soil organic carbon than many other ecosystems. Globally, grassland soils store roughly a third of all terrestrial carbon. That rivals, or maybe even exceeds, forests in the total amount stored, especially over the long haul.
Wow, a third. So the secret is really in the roots. I've heard prairie grasses have incredibly deep root systems.
They really do. Native prairie grasses often stretch down 10, even 15 feet. Most of a prairie plant's actual biomass is below ground, not what you see above.
15 feet, that's amazing.
It is. And each year, a significant chunk of those roots dies back naturally and new roots grow. That process deposits carbon-rich organic material deep into the soil profile. This carbon gets incorporated into stable soil humus over time. That's how those incredibly fertile prairie topsoils were built up over millennia. And unlike trees, which release carbon when they burn, soil carbon in grasslands tends to stay locked away pretty securely, even through things like wildfire or drought.
Okay, so the grasslands are storing carbon deep down. How do cows enhance this? It still feels a bit counterintuitive that grazing animals would help store more carbon.
Well, well-managed grazing can significantly boost this whole soil carbon sequestration process. You have to remember, grasses evolved alongside grazing animals for millions of years.
Right. Coevolution.
Exactly. So when an herbivore, like a cow, bites off the top growth of a grass plant, the plant responds physiologically. It sheds some of its roots. Those shed roots then decompose and become soil organic matter, adding carbon to the soil.
Okay.
And practices like rotational grazing, where animals are moved frequently to different paddocks, allowing rest periods. This stimulates more vigorous root growth. More root growth means drawing down more CO2 from the atmosphere, and the roots also pump out carbon-rich substances, exudates, into the soil that feed microbes, further building stable carbon. There seems to be a sort of Goldilocks zone for grazing, not too much, not too little. Moderate disturbance actually boosts root turnover and drives carbon deeper into the soil.
And this isn't just theory, is it? You mentioned some eye-opening potential from actual studies.
No, it's not just theory. There was a significant peer-reviewed study published in 2018. It found that pastures using what's called adaptive multi-paddock, or AMP grazing, which is a form of intensive rotational grazing, sequestered so much carbon in the soil that it completely offset the greenhouse gas emissions from the cattle themselves.
Completely offset, so net zero.
The study suggested the net emissions were approximately zero or even slightly carbon negative. That directly, fundamentally challenges the narrative that cows are inherently climate villains.
That is a profound finding. But if it's that significant, why are we still so laser-focused on methane emissions from cows as the main problem? Is it just about mismanagement, like you said, or are there other factors simplifying the message we usually get?
That's an excellent point, and it brings us back to management. The real carbon catastrophe isn't necessarily the cows themselves, but how we manage, or often mismanage, our grasslands. Overgrazing can degrade soil and release carbon, absolutely. But far, far worse is plowing under those native grasslands to plant annual crops.
Right, tillage.
The moment you till that prairie sod, you expose potentially centuries of stored carbon to the air. It rapidly oxidizes and goes up as CO2. Scientists report many prairie soils lost 50% or more of their stored organic carbon soon after being converted to cropland. So, keeping land covered in perennial grasses with thoughtful grazing not only prevents those huge losses, but can actually continue to build soil carbon. Properly managed cows in this context can literally help cool the planet by pulling carbon from the air and putting it back in the ground.
Okay, so what does this all mean when we talk about the greenhouse gases themselves? Let's maybe unpack the different impacts of methane and carbon dioxide, because the conversation around them often feels very different.
Yes, that's a crucial distinction to make. Methane from cows, for example, behaves very differently in the atmosphere compared to CO2, especially CO2 from burning fossil fuels.
Also,
Well, methane, CH4, is much more potent in the short term. Depending on the time frame you look at, it's about 28 to maybe 87 times more potent per molecule than carbon dioxide, CO2, at trapping heat. But, and this is a big but, it's also short-lived. It breaks down in the atmosphere in about 12 years on average.
12 years. Okay, and CO2.
Carbon dioxide is less potent molecule for molecule, but it persists for centuries, even millennia. It just hangs around and builds up.
So I've heard this described as methane being a flow pollutant, while CO2 is a stock pollutant. What's the practical implication of that difference?
That's exactly right. Because methane is a flow pollutant, if its emissions stabilize, say, if global cattle numbers stay roughly the same, then the amount of methane in the atmosphere reaches a plateau. The rate of breakdown starts to match the rate of emission. And if you actually reduce methane emissions, you can get a relatively quick net cooling effect. But CO2, being a stock pollutant, just accumulates. Even if CO2 emissions stayed steady, the planet would keep warming because we're constantly adding more to the stock that stays there for ages. To stop the warming from CO2, emissions need to drop to basically near zero.
Got it. And there's another difference too, isn't there? Biogenic versus fossil carbon?
Yes, absolutely. Critical difference. Biogenic methane, the kind from cattle burps or manure, is part of a natural, relatively fast carbon cycle. Plants absorb CO2 from the air through photosynthesis.
Right.
Cows eat the plants. They release some of that carbon as methane, CH4. That methane goes into the atmosphere, and within about 12 years, it oxidizes, breaks down back into CO2 and water. That CO2 can then be reabsorbed by plants again. It's a cycle, recycling existing atmospheric carbon.
Okay, like a closed loop, almost.
Pretty much. But fossil carbon from burning coal, oil, and gas, that's new carbon, being added to the active atmosphere ocean system. It was locked away deep underground for millions of years, completely outside this rapid cycle. Burning it injects vast amounts of extra carbon into the system, overwhelming the natural balancing mechanisms. That's the core driver of long-term climate change.
So the source really matters. When we look at cattle production then, the emissions are more complex than just the methane burps, right? What else is in that footprint?
Oh, yeah. The total bee footprint includes several things. There's the enteric methane we just talked about. There's methane and nitrous oxide, another potent greenhouse gas from manure management. Then there's the whole feed production piece that involves tractor fuel, CO2, fertilizer production, often energy intensive, and nitrous oxide emissions from the fertilizers applied to fields. And then, of course, processing and transport add to it as well. It's a whole system.
Which makes comparing different systems important, like feedlot versus regenerative grass-fed. How do they stack up emission-wise?
It's a really important comparison. In typical feedlots, cattle are fed a lot of grain. They grow faster, so technically, they produce less enteric methane per animal over their shorter lifespan. But you have potentially high CO2 and nitrous oxide emissions associated with producing all that grain feed the fossil fuels for farming, the energy-intensive fertilizers.
Okay. And regenerative grass-fed.
With regenerative grass-fed systems, the cattle grow more slowly, mainly eating grass. So yes, they might produce more enteric methane per animal over their lifetime. However, the fossil fuel and fertilizer inputs for feed production are dramatically lower, often near zero. And crucially, you have the potential for healthier pastures and significant carbon sequestration back into the soil, which we talked about.
And what about the manure difference? That's often brought up as a big problem with cows.
Big difference there, too. In feedlots, you have massive amounts of manure concentrated in lagoons or piles. These can become major hotspots for releasing methane and nitrous oxide.
Right, you hear about manure lagoons.
Exactly. But in a well-managed regenerative grazing system, manure is naturally dispersed across the pasture by the animals themselves. It gets incorporated back into the soil ecosystem more naturally, enhancing soil fertility with significantly lower nitrous oxide emissions compared to concentrated slurry.
And the soil carbon.
That's probably the biggest potential differentiator. Feedlots and the cropping systems that support them typically lead to soil carbon loss over time. Regenerative grazing, as that 2018 study showed, can sequester significant amounts of carbon, potentially offsetting most or even all of the methane emissions. It could become carbon negative or neutral. Fossil fuel use is obviously high in the feedlot system, tractors, transport, feed production, and generally very low in regenerative systems.
What about land use, though? That's always a major point of contention. Feedlots seem more land efficient, don't they?
They require less direct land for the animals, yes, but they rely heavily on vast areas of cropland elsewhere to grow their feed, corn, soy, etc. Regenerative grazing typically requires more land per animal, but critically, it often utilizes land that's not suitable for growing crops anyway, hilly areas, dry lands, etc. And ideally, it's actively improving the health and carbon storage of that land rather than degrading cropland.
So netting it all out.
Netting it out, conventional feedlot beef generally has a significant net greenhouse gas footprint. Regenerative grass-fed beef has a much lower footprint, and depending heavily on the specific management and how much carbon is sequestered, it has the potential to be climate neutral or even negative. The core message really holds. As many experts now say, cows are not inherently the problem. It's the way they're managed and farmed that is creating a climate problem. And even critics of industrial agriculture often agree that the feedlot system has serious environmental downsides.
This really does feel like a complete paradigm shift from what we're typically told in, mainstream discussions. So why haven't we heard this narrative more widely? Why isn't this the dominant story?
Yeah, it's a fair question, and it's important to understand there's often institutional inertia and various external pressures that shape our understanding or misunderstanding of these complex issues.
So why aren't these facts, these nuances, being shouted from the rooftops, so to speak?
Well, part of it is probably just simplified messaging. Mainstream environmental education, media headlines, they often go for the easy soundbite like, cows are destroying the climate. It focuses heavily on methane, often without the crucial context of the biogenic cycle or the potential offsets. This approach tends to ignore the potential positive impacts of regenerative grazing, things like improved biodiversity, helping pollinators, and crucially, carbon sequestration.
And I imagine scientific silos play a role too, different fields maybe not talking to each other enough.
Exactly. That's been a big factor historically. You had soil carbon researchers over here, entomologists studying bees over there, animal scientists looking at methane somewhere else. They often operated in, well, relative isolation. It's like trying to solve a really complex puzzle, but half the pieces are locked away in different rooms. You just can't see the full picture until you bring them all together. Earlier life cycle analyses of beef, for instance, often made assumptions like soil carbon was static, or they only looked at emissions from worst-case overgrazing scenarios. That led to some misleading conclusions, suggesting grass-fed beef was actually worse for the climate. It's only more recently that truly interdisciplinary studies have started integrating soil, carbon dynamics, biodiversity impacts, the whole system, bringing that fuller, more nuanced picture together.
Okay, so there's the complexity in the history.
Yeah.
But you hinted at maybe a less innocent factor too. Vested interests, agendas that might prefer one narrative over another.
Unfortunately, yes, that seems to be part of the story too. There are billions, literally billions of dollars being invested in technological food replacements, lab-grown or cultured meat, highly processed plant-based proteins. These are often marketed very heavily as eco-friendly alternatives to the supposedly evil cow.
Hmm.
You see figures like Bill Gates, for example, who's a very vocal climate advocate. He has publicly called for rich countries to move towards 100% synthetic beef and has also personally invested heavily in companies like Impossible Foods and Beyond Meat, as well as various lab-grown meat startups. This kind of push inevitably highlights every potential negative associated with livestock, while often downplaying or ignoring any positives or the nuances of different management systems.
So it becomes not just about the science, maybe, but also about market share, investment returns, and potentially even a degree of uh, control over the future food system.
Precisely. And this is where you can see greenwashing, maybe even propaganda creeping in. Research funding can sometimes steer university programs or experts towards focusing on solutions that align with high-tech, industrial, or patentable approaches, because that's where big money and momentum might be.
Right.
Holistic, nature-based approaches like regenerative grazing, they can get dismissed as too fringe, unscalable, or simply not modern. It's quite ironic, really, when an approach labeled environmentalism ends up ignoring or even vilifying nature's own established processes and cycles. Real solutions that involve complex ecosystem dynamics, decentralized food production, farmer knowledge, they don't necessarily sell expensive new products or require massive centralized infrastructure, which can threaten those who are aiming for more control over food and maybe even carbon markets.
And there's a real risk, isn't there, in fighting climate change in a way that ignores the broader ecology. You could end up with unintended negative consequences.
Significant ones, yeah. For example, imagine a scenario where everyone abruptly switched from well-managed beef produced on grasslands to, say, soy-based patties. If that demand surge led to more plowing up of native prairies in North America, or more clearing of the Amazon rainforest for soy monocultures, you'd get a massive release of stored soil carbon. Plus, you'd destroy vital pollinator habitat and biodiversity hotspots.
So you solve one problem maybe, but create several others.
Exactly. It potentially removes the crucial keystone role that grazing animals, when managed properly, can play in maintaining the health and function of those grassland ecosystems. Fortunately, though, there is a growing coalition, farmers, scientists, even some environmental groups who are highlighting these complexities. They're recognizing that livestock aren't inherently the enemy. It's often the industrial misuse of them. Divorced from ecological principles, that's the core problem.
This deep dive has definitely challenged a lot of assumptions about our food system, the environment, these connections. So let's tackle some of the common objections and concerns head on. People listening might still have questions, so let's try and cover those to give a complete picture. What are some of the most frequent environmental, ethical, or economic objections that come up when discussing this more positive role for cattle?
That's a really critical discussion to have because many of these objections are absolutely valid points when aimed at industrial, feedlot-style agriculture, but they often get misapplied or oversimplified when talking about well-managed regenerative system.
Okay, let's start with the big one people always bring up, methane. Isn't cattle farming still a leading cause of greenhouse gas emissions, even with the nuances?
It's true. Cattle emit methane, and methane is a potent greenhouse gas, no doubt about that. But the overall impact is often exaggerated in the public conversation. Here in the U.S., for instance, all of animal agriculture accounts for about 3.9% of total national greenhouse gas emissions. Beef cattle specifically are around 2% of that total.
Only 2%. That sounds much lower than often implied.
It is for the U.S. context. Globally, the livestock sector's contribution is estimated at around 14.5% by the FAO. That's significant, definitely not trivial, but it's still not the majority source of global emissions, which is fossil fuels by a large margin. And maybe more importantly, we need to circle back to that point about methane's short lifespan, about 12 years.
Right, the flow versus stock idea.
Exactly. If global herd sizes remain relatively stable, as they have in many developed countries, they don't add significant new warming over time because the methane being emitted is balanced by the methane breaking down from previous years. It's replacing itself, unlike CO2, which just keeps accumulating. So simply forgoing meat, while a personal choice, isn't the climate panacea it's sometimes made out to be, especially compared to tackling fossil fuel use.
Okay, what about deforestation and land use, particularly in places like the Amazon? That's a huge, visible issue, and cattle ranching is often blamed directly.
Absolutely. And the situation in the Amazon is devastating. Estimates suggest 60 to 80% of deforested land there ultimately ends up as cattle pasture. This is clearly unsustainable and a critical environmental crisis.
So cows are the problem there.
Well, it's more accurate to say it's a problem driven by complex factors. Specific government policies, or lack thereof, powerful economic incentives favoring land speculation and commodity beef production, insecure land tenure, and global market demands. It's fundamentally a land management, governance, and economic issue, not simply an inherent consequence of cows existing. We have to remember globally, something like 65% of agricultural land is grazing land, and much of that is marginal land, too dry, too steep, too rocky, unsuitable for growing crops. The solution in places like the Amazon involves tackling the drivers of deforestation, improving land use practices, and incentivizing sustainable, non-destructive grazing systems, rather than concluding we must eliminate cattle everywhere, especially where they can fulfill a positive ecological role on appropriate lands.
Got it. Another very common objection is resource use, that cows consume enormous amounts of water and feed, making beef an incredibly inefficient way to produce protein compared to plants. How do you respond to that?
This is another area with a lot of misunderstanding, particularly around water. When you see huge water footprint numbers for beef, typically around 93% or more of that is actually green water.
Green water, what's that?
Green water basically means rainfall that falls on pastures and fields, is used by the plants the cows eat, and then cycles back into the environment through transpiration and evaporation. It's part of the natural water cycle. It's not blue water, water withdrawn from rivers, lakes, or aquifers for irrigation or drinking, which is usually less than 5% of beef's total water footprint. So cows aren't typically guzzling thousands of liters of precious drinking water.
Okay, that clarifies the water part. What about feed efficiency? They eat a lot for the meat we get, right?
They do eat a lot, but what they eat is key. Ruminants, like cows, have this amazing ability to digest fibrous plant material, grass, hay, agricultural byproducts that humans absolutely cannot digest. Globally, about 86% of what livestock eat is estimated to be human inedible feedstuffs.
86%. So they're not primarily competing with humans for food?
Largely no. They are essentially upcycling biomass that would otherwise be indigestible for us or grown on land unsuitable for human food crops and converting it into high-quality, nutrient-dense protein with complete amino acids, vitamin B12, iron, zinc, that are often harder to get in sufficient quantities from plant-only diets. In well-integrated systems, they can actually complement crop agriculture by utilizing crop residues or grazing cover crops, turning potential waste into valuable food.
That leads to the scalability question. Can sustainable cattle farming, even regenerative grazing, really scale up to feed a planet with billions of people? It sounds great in principle, but is it realistic globally?
That's a fair challenge. If the goal is for everyone on Earth to eat large portions of industrially produced grain-finished beef every single day, then no, that's almost certainly not ecologically sustainable or realistic.
Okay.
But having some animal protein, including beef from well-managed systems, as part of diverse global diets is likely achievable, especially if we focus on improving how we raise livestock. We need continuous improvements in efficiency. For example, the U.S. today produces more beef with significantly fewer cattle than it did back in the 1970s. That's a massive gain in efficiency already achieved through genetics, nutrition, and management. And while alternative proteins like plant-based and maybe eventually cultured meat will likely play a growing role, they also come with their own environmental and resource challenges, reliance on monoculture crops for inputs, energy-intensive processing, questions about nutrient bioavailability, and their own carbon footprints from production and supply chains. Supporting farmers globally to adopt regenerative practices that enhance ecosystem services is arguably a very scalable approach to producing nutrient-dense food more sustainably.
And circling back to climate goals, when policymakers talk about achieving net zero, many people assume that requires eliminating all methane emissions, including from agriculture. Based on what you said earlier, is that accurate for biogenic methane?
Not entirely, and the distinction is crucial for policy. Achieving net zero for long-lived greenhouse gases like CO2 essentially means getting emissions down to virtually zero because any emission adds to the accumulating stock in the atmosphere. But for short-lived gases like biogenic methane, the science suggests something different. Because it breaks down relatively quickly, stable emissions don't lead to ever-increasing warming. They lead to a stable level of warming contribution. Therefore, achieving overall climate neutrality doesn't necessarily require eliminating all biogenic methane. It means we need to stop increasing these emissions and ideally work to gradually reduce them through things like feed additives that reduce enteric methane, better manure management, and especially by maximizing the carbon sequestration potential in the soils of grazing lands. In fact, agriculture managed regeneratively could potentially become a significant source of carbon offsets needed by other sectors that are harder to decarbonize. We don't need to eradicate cows, we need to manage the whole system better.
Let's shift to ethics for a moment. For many people, regardless of the environmental arguments, the fundamental issue is the ethics of killing animals for food when plant-based alternatives exist.
Yeah.
How does that perspective fit into this broader discussion?
That's a deeply held and important ethical consideration for many people, and it deserves respect. The abuses and suffering inherent in many industrial factory farming systems are rightly condemned by people across the spectrum.
Definitely.
From a purely ecological or anthropological perspective, humans evolved as omnivores. Eating animals has been part of our species' history and survival strategy for millennia, placing us within the natural food web. It's also worth acknowledging, though sometimes uncomfortable, that large-scale industrial plant agriculture isn't without its own ethical dimensions regarding animal life habitat destruction displaces wildlife, and plowing and harvesting inevitably cause deaths of field-dwelling animals.
That's a fair point, often overlooked.
For many who choose to include animal products in their diet, the ethical focus shifts towards how the animals are raised and treated during their lives and at the time of slaughter. The argument is that ethical farming means providing animals with a life that allows them to express their natural behaviors, like grazing on pasture, minimizing stress and suffering throughout their lives, and ensuring a humane end. Regenerative systems often align much better with these animal welfare goals than confinement systems. Ultimately, whether or not to eat animals is a personal philosophical choice, but ethical omnivory, focused on sourcing from high welfare, ecologically sound systems, represents a valid middle path for many, addressing cruelty concerns without demanding complete abstinence for everyone.
Is the push for meat eating, or defending it, just about corporate greed from the meat industry?
Greed and profit motives certainly play a significant role in shaping the industrial food system, absolutely. But that's true across the board. It's not unique to the meat sector. You see similar dynamics of consolidation, focus on cheap inputs, externalizing environmental costs, and generating waste in large-scale industrial production of commodity crops for processed foods as well.
Right, it's systemic.
Exactly. The fundamental problem might be less about meat itself and more about treating food primarily as an industrial commodity optimized for profit, rather than as a vital source of nourishment embedded within ecological and social systems. So the solution arguably involves reforming the incentives across the entire food system, supporting local and regional food networks, promoting sustainable practices for all types of food production, and maybe shifting subsidies away from degrading practices towards regenerative ones, not just demonizing one particular food group.
On that point about subsidies, if we support cattle farming, even regenerative kinds, won't that just end up lining the pockets of big agribusiness anyway? Should governments be subsidizing this at all?
That's a really important concern about where the money flows. Government subsidies are already deeply embedded in agriculture, especially in countries like the US, and they often have perverse effects, for example, heavily subsidizing the production of commodity crops like corn and soy, which are key inputs for feedlots and processed foods, and which are often grown in ways that degrade soil health.
So subsidies are already shaping the system maybe in the wrong way?
Precisely. So the argument isn't necessarily about starting subsidies for cattle, but about fundamentally shifting existing agricultural support away from subsidizing environmentally damaging practices towards actively rewarding regenerative ones. This could mean payments for ecosystem services, paying ranchers directly for verified outcomes, like tons of carbon sequestered in their soil, improvements in water retention, or measured increases in biodiversity and pollinator habitat on their land.
Paying for results, basically.
Paying for positive environmental results. Some analyses suggest this could actually be a more cost-effective way to achieve climate and environmental goals compared to relying solely on expensive high-tech carbon capture or geoengineering solutions. However, and this is crucial, careful program design is absolutely needed to ensure these funds primarily benefit actual family farmers and ranchers doing the work on the ground, rather than just being captured by the largest corporate players. It requires accountability and targeting.
What about the threat from new food technologies? Won't things like plant-based burgers and eventually maybe cultured or lab-grown meat just bankrupt traditional farmers anyway, regardless of how sustainable they become?
That's certainly the narrative pushed by proponents of these technologies, but it's not necessarily a foregone conclusion. While plant-based meat alternatives have seen noticeable growth, it's still from a relatively small market base compared to conventional meat, and growth has slowed recently. Cultured meat faces very significant hurdles in terms of scaling up production efficiently, reducing costs to be competitive, high energy requirements for the bioreactors, and consumer acceptance.
So it's not an overnight replacement.
Likely not. Traditional farmers, particularly those using regenerative methods, can remain competitive by focusing on quality, distinct flavor profiles, nutritional advantages, traceability, animal welfare, and the positive environmental story associated with well-managed grazing. They can build trust and loyalty with consumers. We also have to remember that rural economies in many parts of the world are deeply intertwined with livestock farming. Supporting farmers to innovate and adapt towards more sustainable, resilient models can help prevent economic collapse in these communities rather than just assuming they'll be displaced by technology.
One last practical concern. Even with subsidies or support, won't implementing these environmental measures, changing grazing practices, monitoring soil carbon, etc., bankrupt many farmers who are already operating on incredibly narrow margins? How can they afford the transition?
That is a very real and critical concern. Imposing rapid, unfunded mandates or expecting farmers to shoulder the entire cost of transitioning to new, potentially more complex systems can indeed threaten the viability of many farms, especially smaller family operations. This could ironically lead to further consolidation by large agricultural corporations who can afford the investments.
So transition support is key.
Absolutely crucial. That's why any effective policy needs to incorporate robust financial and technical support for farmers during the transition period. This could take many forms. Grants for infrastructure changes, like fencing and water systems for rotational grazing, cost-share programs for adopting new practices, technical assistance and education, access to low-interest loans, or even guaranteed purchase agreements for products certified as meeting high environmental standards.
It needs to be a partnership, not just a burden.
Exactly. We also need to recognize that doing nothing is not a viable option either. Climate change itself, with more extreme weather events like droughts and floods, poses a massive threat to agricultural productivity and farm viability in the long run. So investing in regenerative, resilient farming systems is also a form of risk management. It's about enabling a just transition, actively helping farmers adapt, innovate, and become part of the climate solution, rather than simply imposing rules that could put them out of business.
This deep dive has truly been fascinating. It's really challenged so many assumptions, hasn't it? It's shifted my understanding of how intricately connected these ecosystems are, and it really highlights how cows, when managed thoughtfully, regeneratively, can actually be a vital part of climate and ecological solutions, not just problems. Remember, we talked about CO2. That's useful too.
Yeah, it's a much more complex picture than we often get. And perhaps the final thought to leave with you, the listener, is this. Instead of just seeing perceived enemies, like cows in the climate debate, where we once saw only conflict, what might happen if we tried to align our agriculture, even our own landscaping, more closely with nature's inherent balance?
Thinking cows and bees together, like you said, instead of seeing it as either.
Exactly. And it makes you wonder, what other perceived enemies in our environmental discourse might actually turn out to be potential allies or part of a solution if we just re-examined our approach with a more holistic ecological lens?
That's a really provocative thought. We definitely encourage you, our listeners, to reflect on maybe your own yards. Could you let some clover or dandelions grow? Maybe plant a small wildflower patch. And perhaps think about your purchasing choices too. Supporting regenerative farms when you can is like voting with your wallet for practices that aim to heal the land.
And maybe urge the environmental organizations you support and policymakers to broaden their view, to look beyond just emissions cuts alone and really focus on integrating conservation into our working lands, supporting farmers as stewards, and championing these nature-based solutions.
Absolutely. Until next time on The Deep Dive, keep digging deeper.